All right, let's get going. Good morning. Welcome back to my stream, and let's start taking a look at something new today, because I want to take a quick break from the editor that we've been working on, and not the the interpreter we've been working on, so we can look at making an editor. So we've gotten up to chapter 26 of crafting interpreters, and I haven't yet read over this chapter, but this chapter is all has to do with the C code having to deal with managing the memory, managing its own memory. And in LOX manages the memory for us as long as we're just using the standard tools that are provided, like RCs and boxes and things like that. And because we don't need to do any of garbage collection, I figured, okay, let's take a day off. And let's take a look at this thing that I was poking around at yesterday. It's a short tutorial, which I haven't gone through, so I don't know how good it is. But I want to try porting it to Rust anyway, to see how to go about doing that. Again, it's part of my learning how to Rust thing. So let me set up my little window over here so I can see what's going on, and then. Yeah, let's create a new repo. This is crafting interpreter dev. Okay, so what do we got here? Let's create a brand new repo. There's this thing here. Let's go to my top level. Let's create a new repo. And what are we going to call it? Good question. We don't need that. We don't need. Oh yeah, this is a cross-term search. Okay. Yes, this is the other thing I want to work on. Let's put that over here. And we don't need inheritance there. Okay. This is an instruction booklet that shows you how to build a text editor in C. The text editor is Antires's Kilo, okay, with some changes. It's about 1,000 lines of C code. Oh, I see. So the Anti-Res wrote an editor. Oh, and screencast it. And then somebody turned it into tutorial. Neat. Okay. It's 1,000 lines of C file with no dependencies, and it implements all the basic features you'd expect in a minimal editor, as well as syntax highlighting and a search feature. Okay. This book walks you through building the editor 184 steps. Each step you'll add, change, or remove a few lines of code. Most steps you'll be able to observe the changes you made by compiling and running the program immediately afterwards. All right, you're going to build a text editor from scratch. Okay, so yeah, this says no dependencies, right? And I'm going to use cross terms, so that's already introducing dependencies. So let's like I said, let's create our new repo. And what's the name of the Kilo? Kilo ed, sure. A port of the Kilo editor tutorial to Rust. Sure, add a README. Sure, add a Rust. Git ignore. MIT license. Boom. All right, so let's grab a copy of that. I don't know if this will work. This might work. Let's find out. Git clone. Boom. Yes. Okay, so we have Kilo ed. Oh, 1 second. I'm getting an urgent text message. Okay. All right, and let's go. Oops, I have to hit tab. There we go. Cargo run. All right, actually, I want to do it in this window because this has the larger font. Oh, of course, I have to create my own cargo. Oh, yeah, if I do this, that's one of the disadvantages of going through here. We don't get a cargo for free. Move Kilo ed to K. Sure. Cargo new Kilo ed. And then in here, Kilo ed, we'll just say move cargo and source to K. Move that and move this back. I don't know if there's a better way to do it. Cargo run. We should get hello world. Okay, good. And git status. Git add source. Git commit initial repo. There we go. Actually, what's the first commit called? Initial commit, and this is initial repo. Okay, very good. So what we need to do is start from scratch. If I want to add the Kilo ed, cargo add crossterm. Because what crossterm provides is the ability to use the terminal as a I/O system, right? As a user interface. And there's all these. Put a rectangle colored with magenta and use both direct execution and lazy execution, whatever that means, and we'll learn. So let's just try this out. I can just create a new temporary repo, cargo new. We call it Spike, I guess. Apply a cross term to that, and then main, paste that in, cargo check. It's got to build everything, so it might take a little while. There we go. Cargo run, prints a colored magenta, a rectangle colored with magenta. And indeed it does. Look at that. No new line, but that's okay. Looks like it went off the edge of the screen there. It goes to 150. So, but I'm sure it's, yeah, look at that. Trying to make that wider doesn't work. Let's try running it again. There we go. And in doing that, it's going to make it look funny too. Okay. All right. So we have crossterm up and running. Let's see what we do here in terms of building our own text editor. If we're ready to begin, go to chapter 1. I assume it's the same as setup. Yeah. Okay. Lego. Don't you love a fresh start on a blank slate? Selecting a singular brick onto which you build your entire palatial estate. Yeah. Unfortunately, when you're building a computer program, step 1 can be complicated. Oh, okay. So yeah, step 1 is install C. Okay. I actually do have C in here, don't I? Yeah. But we're not going to be using C. We're going to be using Rust. And I don't like the fact that this border business is going on. Okay, that's better. We don't have to worry about compiling with make. So step 1 is, yeah, Step 1 was very, very easy to do. Let's go to the next chapter. Let's try and read key presses from the user. Lines you need to add are highlighted. So this is just a basic loop, and it's checking to see as long as there's a character to read, then read it and don't do anything. So just loop and don't do anything. So that's easy enough to do in Rust, right? We don't want to be in our spike, we want to be in our kilo. This is just loop. We do some read thing. And then we want to, when do we want to exit? We want to exit when we run out of characters to read. So let's find out what capabilities crossterm gives us for reading. Does it have any? It must. Crossterm event read. Oh, this is a little loop that prints events. Okay, that's easy enough to do. We can just say use crossterm event read and result. I guess we can do this here, result. Right? And then we can just say, this will print it out. That's fine. So println and the question mark just means, you know what? Actually, what we should do is say if let OK event, right? We're getting event equals read. Then we'll print the event. Otherwise, if it's an error, we'll break. And I guess that's as close as we can get to this, right? While so the read returns how many bytes were read. So if we read 1 byte, and returns 1 byte. If it doesn't read any bytes because standard in got closed, if somebody hit Control D, then we'll return. So we can do that here. And I'm sure we can get out of it with the Control C also. Expected result bool because of return type. Oh, right. Okay. Actually, Rust 161 just came out. Main can only return types that implement termination. Yeah, 161 just came out with that. I think I can do this, right? I can just do that and not worry about the... Yeah, okay. That might be easier. All right, so let's try running that. Oh, right. Yes. I was expecting it to be on each character, but it isn't. We were actually in what's called canonical mode, where you read a line at a time. So there's all the characters I typed, and then the enter key, and then it waits. If I hit Control D, nope. It doesn't care. And Control C gets me out. Okay. When you run Kilo, your terminal gets hooked up to standard input. Right, so that's what we were doing there. Here it is. By default, your terminal starts in canonical mode, also called cook mode. In this mode, keyboard input is only sent to your program when the user presses enter. Right, so that's what we saw here. This is useful for many programs. It lets the user type a line of text, use backspace to fix errors, and so on. But it doesn't work well for programs with a more complex user interface, like text editors. What we want is raw mode. Fortunately, there's no simple switch you can flip to get the terminal to raw mode. Okay. Except, I bet you there is in crossterm raw mode. Right, let's look yeah, enable raw mode. Please have a look at the raw mode section. Input will not be forwarded to the screen. Input will not be processed on enter press. Input will not be line buffered. Input set byte by byte to input buffer. Special keys like backspace and Control C will not be processed by terminal driver. New line character will not be processed, therefore println can't be used. Use write instead. New line character will not be processed. All right. So this is output. Special keys like backspace and Control-C will not be processed by the terminal driver. Okay. So that means if we tried to flip to raw mode, we're going to have some interesting fun, right? So press Q to quit. To demonstrate how canonical mode works, we'll have the program exit when it reads a Q key press from the user. Lines you need to change are highlighted. All right, so we can do that here, right? We can make a quick change and say, oh, we have to figure out what this event is in order to read it. Look here, it's a key event with a code in it. So that means I have to say if let, what was it, key? Yes, key comes with a key event. Key event equals event. Then we want to say key event. Oh, I should look here, right? Why am I looking there? And I can look here. Key event, here it is, has the code. And the key code is what? Show 18 variants. Char. Right, that's what we were seeing, right? We were seeing the char. Yeah, we're seeing char here. Okay. Modifiers none. Oh, interesting. So this would tell us which modifier keys are used. Okay, so key event is going to be a key event which has key code in it. So we say if key event dot code, and it's pub, so I can just reach into it like that, is equal to key code char q, right? We're looking to quit, then break. Else we'll print out the key event. Does that work? Oh, I probably have to include, yeah, all these things in scope here. We have event, read, and key event. And where does key code come from? Key code. Oh, and key. I'm missing key. Event key. Okay. Can I do that? I can. Oh, warnings. What are the warnings? Key events not used. Oh. Okay. There we go. So now if I run it, it's saying it's still not doing canonical. I mean, it's still doing canonical input. But if I have a Q in there somewhere, which I just put, we hit the Q and we exit. All right. Nice. Okay. This is all standard stuff though, right? I mean, we haven't really gotten into anything fancy. To quit this program, you have to type a line of text that includes a Q. It'll read one character at a time until it reads the Q, at which point the while loop will stop and the program will exit. Any characters after the Q will be left unread on the input queue, and you may see that input being fed into your shell after your program exits. I did not, so I guess something else is consuming them, or they got read into the buffer in the Rust program and they got thrown away on exit. We can set a terminal's attributes by using tcgetAttr to read the current attributes into a struct, modifying the struct by hand, and passing the modified struct to tcsetAttr to write a new terminal attributes back out. So I think we're going to be able to skim through this really quickly just using the enable raw mode, right, that we saw before. Right, enable raw mode, and then I guess at the end I want to do a disable raw mode. And they both have results. Okay. So I can say here at the top, terminal, if I import cross-term terminal, enable raw mode, question mark. And then here I can say disable raw mode, question mark. All right, so if I do this, now we should be able to get the characters one at a time, right? Cargo run. Yeah, okay, so that's what I was saying before in the raw mode section is you shouldn't use println. use right instead. I don't know why. I mean, println works. I'm hitting J over and over again. Well, I think what we need to do is add the, oh, I can't hit Control C. Fortunately, Q works. I hit Q and we got out. Yeah, that's right. So here's Control C. You can see that. Let's put a new line, carriage return on there, because I think that's all it's missing. If we do that. Yeah, okay. And if I hit Control, yeah. Oh, that's Shift. Here's Control. Neat. Oh, but that's interesting. So we get the modifier of Shift, but we also get the uppercase character. That's interestingly annoying. And if I hit Q, I'm done. All right. And then we're back to line at a time mode. Okay. So this is, we kind of get this because the maintainers of Crossterm did that for us. So the echo feature, right? So we're talking about each feature. This is the echo feature. Notice that the character I typed is no longer showing up, but by enabling raw mode, nothing gets echoed from what I type. Normally you type a character and automatically gets echoed by standard in, from standard in to standard out. But turning off echo disables that. And then there's disable raw mode and exit. So what this is doing is it's storing the term.io info into a global variable and then restoring the global variable on exit. Here's canonical mode, right? This is the byte by byte rather than line by line. And again, our enabled raw mode from Crossterm will do that. So this is the no echo. This we haven't talked about yet, but here's canonical mode, right? So that's that line there. So how many more are these? Display key presses, right? So we're just printing out. Oh, I see. Yeah. So if there's an is control. So we just get a byte out of this, right? And the byte's going to be on the ASCII table. If you look at ASCII table, you can see the first. I shouldn't look at octal. Let's look at decimal. The first 32 are all considered control codes, right? We have null, start of header, start of transmission, end of transmission, and so on. And all that, I forget what they all stand for. And one of these is escape. Probably 31 is escape. I don't know what US means. And then 32 onwards are non-control codes. So I think is control is just checking to see that are the upper 3 bits clear, right? Because the first 5 bits are taken here. Yeah. And that's all this is doing. So you can tell if it's a control, but in our version, we can see the control here, right? So we have to look at modifiers. And I bet you if I hit 2 modifiers, let's say I do Control-Shift-G. Oh, I only get one of them. I can't do Control-Shift-G. If I do Control-G, that works. If I do Shift-G, that works. Control-Shift-G only does Control-G. I wonder if there's a cross-term setting for that. Because it'd be nice to be able to do that, right? To see all the modifier keys that are being pressed. Okay, so arrow key. Oh, let's take a look at the arrow keys. Do those get translated? They do. Up, down, left, right. I can go Control for each one, or Shift for each one, and then of course Control up gets captured to this. Control right and left go there. Control down. Oh, sorry. Yeah. Control down does that. Control right shifts there. Control left shifts there. Okay. You still get them. It's just that other things happen. If you happen to press Control S, you might find your program seems to be frozen. I don't know if. Let's see. Control S. No, it's not frozen. Oh, and Control Q quit also. That's interesting. Because all we're doing is checking the... Oh, we don't want that. We don't want that. Wow. Okay, that was bad. All we're doing is checking to see if the character is Q, and we're not checking the modifiers. We should check the modifiers for none. All right, and then turn off Control C and Control Z. I think those are already off. Control C, Control Z. Yep. So we can't kill the program with Control C. I bet you we can P-kill it. But it won't disable. Yeah, we're still in raw mode. Sort of, kind of. Yeah, see that? The new lines aren't happening. But if we do it that way, then we reset the terminal. Now everything's working. Okay. So you don't want to P-kill your program because that won't allow you to clean up the raw mode. We don't have to worry about disabling Control S and Control Q because it looks like Crossterm is doing that for us. Control V is probably also... Oh, I guess we didn't. We didn't completely clean that up, did we? That works. Yeah, we're not completely clean. So let's look at which was the thing that did that, because we can turn that on. We can turn that back on. iCanon. That should be okay, right? STTY. Where is it? -A. It should be canon. Yeah, okay. Huh, it is on. If it had a minus sign in front of it, it would be off. Maybe it's these guys? Echo E, Echo K? It might tell us here, Echo E. Erase character shall not visually erase. Echo, do not echo new line after a kill character. Kill character shall not visually erase the current line. Okay. Do not echo new line even if echo... Oh, echo NL. Echo NL. Let's try that one. STTY echo NL. No, that didn't do it. I should have preserved the... now I can't hit Control C. So now my terminal's messed up, and the Crossterm is probably just saving and restoring the broken state, which is a shame. Okay, so let's close out that window and try again. New window. That's the easiest way to get out of the problem. There we go. All right, so don't do that again. Lesson learned. Knock, hi, how are you? We are currently working on making an editor in Rust. Reporting this thing. All right, so this displaying key presses, right? I got to figure out what was going on there. You know what we can do is STTY has a way of saving. Yeah, STTY-G. Yeah, so I can paste this into a file, documents STTY, and then if we get messed up, we can always restore it using STTY. Yeah, we can just say STTY documents STTY.text, and that'll restore the terminal the way it's supposed to be. Okay, so in fact, I probably should just make this a little command. Anyway, post processing of output. Okay, so fortunately we don't have to do any of this stuff. A timeout for read. Okay, so this is new. Currently, read will wait indefinitely for input from the keyboard before it returns. What if we want to do something like animate something on the screen while waiting for user input? We can set a timeout so read returns even if it doesn't get any input for a certain amount of time. Oh, the vmin and vtime. if we take a look here, do we see those anywhere? Yeah, there's min right there. Min equals 1. I don't see time though. There it is, time equals 0. So basically it's the opposite, right? Vmin is 1, vtime is 0. It means wait forever for at least one character. But here we flip it around. We say wait for up to 0 characters for 1. Now, what does 1 refer to? Not there. You set it to 0, so read returns as soon as there is any input to be read. Vtime, since the maximum amount of time, that's 1/10 of a second, 100 milliseconds. All right, so that's what that 1 means. It means wait up to 100 milliseconds for a character, and if you don't see one, return. If you're using Bash on Windows, you may see that read still blocks for input. So crossterm will still block for has been blocking on input, right? As far as I know. We're not incrementing anything other than let count equals 0. We'll just count plus plus. And we can print out count. Key event. You gotta remember I can do that. Okay, so if I say cargo run, yeah, so we're only incrementing once. Oh, I should change it to the loop. That was dumb. I want to count plus equals 1 inside the loop here. So every time we come through the loop, right, we only get 1 character at a time through the loop. Yeah. So we're blocking on read right now. Is there a non-blocking? Let's find out. Block. Oops. Black, block, cursor shape block, color black. Is there a poll? There is. Checks if event is available. Okay. And that's a timeout. So we, instead of using the terminal, right? So this is by setting it here, right? We're telling the terminal processor to do this for us. Right, we issue a read, and we will get back control after 100 milliseconds by setting these things. It looks like crossterm works differently, where we'd have to actually call poll ourselves and say wait for 0 duration. Says poll function must return immediately with event availability information. And here's from millis 100, right? So this will allow us to do a similar thing. So if we do this, if we run it this way, right, with this kind of timeout, that means the read's going to time out after 100 milliseconds, and it's just going to keep printing the previous one 10 times a second until you press a Q. When you run the program, you can see how often read times out. If you don't supply any input, read returns without setting the C variable, which retains its 0 value. Oh, yeah. So you see zeros getting printed out. If you type really fast, you can see that read returns right away after each key press, so it's not like you can only read 1 key press every 10th of a second. All right, so we can emulate that using this poll, I guess. And I want to get rid of this else break, right? So we can just say poll duration from millis 100. And then we have to add poll over here. Event poll. And we'll also have to use standard time duration. All right, does that build? 2 warnings. Oh, and unused results. I guess we can just throw it out because we don't care what the result is. We'll just go ahead and try to read. Actually, why isn't this telling us? It's returning a result. Checks to see if it returns OK true if an event is available. Otherwise, returns OK false. OK true guarantees that subsequent call to read function won't. Can I submit a PR for the fixing the typo? Won't block. So I can say this: if let OK true equals this, and then we can read. Except I don't want to shift everything over like that. And now we get this nice pyramid thing going on here that I don't like. But this is just test code, right? Cargo run. Oh, I had Q. That was dumb. I was typing QWERTY. 19, 29. So this is the count. So you can see the count is going up. I'm not printing out the thing 10 times a second. If I can get 2, 3, 4, 5. I can type it really fast, faster than 10 times a second, and I'm getting sequential numbers. I just tried Control C. Let's try, instead of doing this, we can say let key event equals none. And this, we can say then, C equal to key event, like that. And then close, and then we can say if C is sum, we could do this. There, right? Okay. Oh, if this should be a C, right? And now we don't have key event. We have C. Oh, some key event. If some, can I shadow it this way? Well, let me do that. If let some. Oh, code. There, two warnings. What's the warning? Oh, count's no longer used. Okay. And I can't do it there. Okay. So this should give us the 10 times a second thing, except it's not. Oh no, that's right. It's not printing it out if it's none. So I broke everything. So actually I do want this because I don't have the whole thing. Some key event, C.code, like that. So we can just say else println no key. Right, and that way we can see it running 10 times a second. I can get 3 key events in there all at once. Neat, and I hit Q to quit. Okay, so that's kind of the thing that they were going after here, where we could see the zeros coming out every 10 times a second, but you could type multiple keys at once. You don't have to wait 10th of a second for each character, because that's the way the poll is working. Okay, Samuel Code, hi. All right, and then we'll add a die function that prints an error message and exits the program. Oh, this is with p error. Does Rust have access to Erno Rust or no? Because there must be some libc stuff in here. It is a crate, cross-platform interface to the Erno variable. It's not built in. That's disappointing. So now I'm questioning whether or not I want to do it, but it might be that Crosstream already pulls it in. How do I find out? Depths. Oh, Shrishak. Yeah, I'm not searching for the libc crate. I was hoping to so but thank you for that. I didn't know there was a libc crate. I was looking to see if Rust had a built-in, like a standard error or no thing. It looks like there's an external one. But then I was looking to see in Crosstream, does Crosstream already use something like that? Is it cargo doc? How do you build the docs for your stuff? Yeah. Parking lot. Yeah. Crosstream is very small. I mean, compared to other dependencies I pulled in, this only has a few, right? But now I should be able to access the documents. Standard process exit with the error code. Yeah, so that's right. So that's one thing, is how do you exit with the right error code? And this would be that. But Erno is something that's part of libc, and it's a p error is something that will print out. It'll translate the error. If you say man Erno, for example, right, you get all the error codes that you could get back from any system call. So whenever you make a system call like read, it can return ebusy, for example, or access if you don't have permission or whatever. And then p error will translate that. Oops. P error will translate. There's no comments here, but it should translate it into a, where's the source? Into a string for you, and libc does that. So it all it does is translate it into the string that's over here. File exists, improper link, too many open files, that sort of thing. And that's all I was looking for here, because if we get an error, we want to report what the error is. Most C library functions will fail. We'll set a global errno variable to indicate what the error was. P-error looks at the global errno variable and prints a descriptive error message for it. It also prints a string given to it before it prints the error message, which is meant to provide context. So in a C program, for example, you can say, oh, Samuel Coe, thank you for the follow. I think p-error is an old thing. Do people still use p-error these days? Yes, they absolutely do. Let me make a quick, I created a spike here, vim, nvim, x.c. We could do that and just say int main, int fd is equal to open blah blah blah. Doesn't matter because I'm trying to generate an error now. I can say now printf errno equals this fd errno, and then we can say actually p error, which dumps this text out to standard error followed by a colon followed by the description of the thing. Include standard io.h, include errno.h. So now will this work, or is this going to be a implicit function? That's okay. I think it's standard lib. Oh, it didn't compile it. That's annoying. With that warning. I think it's standard lib. Nope. Man, S2 open. FCNTL. That's what it is. Okay. Oh, right. I need to give it an argument. Let's just take a look. Command S2 open. Open flags. It's open for reading. All right, one more try. There we go. So now if I say a.out, the error node gets set to 2. We see the text that I printed, and then p_error actually appended this to it, and that went to standard error. This went to standard out. This went to standard error. Wish there were a way to... Oh, I guess I can show it by doing this. Dev null. So the error node equals 2 will go to dev null, and this should go to standard error. Inappropriate ioctl for device. That's interesting. I wonder what ioctl it was trying to do. Anyway, so p_error is very definitely used for anytime you use libc, you're going to use p_error, or you may use p_error to print the error code if you don't want to handle it some other way. Any other jobs? Good. Okay. So, how do we want to do it here? Do we want to pull in errno? Or do we want to just ignore the whole problem? I guess we can edit cargo add errno. And then we can take a look at how are they using it here. How are they calling die? Oh, if one of these things fails. That makes sense. If the read fails. Right, see, we check E again. We should also be checking E enter. But maybe we don't even need this. Errno and E again come from errno.h. These system calls, libc calls return -1 on failure and set errno. A good way to get that to fail is to give your program a text file or pipe the standard input of your terminal, and then it'll fail. Okay, I wonder if that'll work for cross-term too. Echo hi, cargo run. Whoa. Oh, and now I can't kill it. Yeah, and now this thing is broken. So stty. There, okay, fixed. So the poll was timing out immediately, and probably because it was setting an error, saying there is an error that we need to handle. And I'm not handling the error here. I'm surprised. Oh, because this. So if this fails, we should report the error, right? And this, unfortunately, is very basic in terms of, let's see, we have this. We can print the errno. And then break. Let's try that and see if we get similar kind of things. So we can just say, oops, use errno. Okay, cargo run. Oh, sorry, echo hi, cargo run. Nope. You saw the cues I was trying to type. So that means read is not returning an error. That's interesting. Right, because if read failed here, I would have expected to see this come out. But maybe the poll is failing. Right? Maybe the poll is failing. Read fail and poll fail. Let's find out. Yeah, poll fail. Inappropriate ioctl for device. Okay, so we're getting we have something similar to what they're talking about, except they created a separate die function for it. And maybe we'll need to do that now. So I guess we should start putting together these helper functions and stuff. It looks like they're going to be doing the entire editor in a single file, right? That's what they said at the beginning. It would be nice in Rust to break things up a little bit. So we don't need to do this in a separate file, but we do want to be able to end the program cleanly. So let's make a die function. And we're giving it a string. What did I say? Into S is into string. SS. Let's call it message. Let's be a little more descriptive. And this will be terminal display disable raw mode followed by the message from p_error. Oh, that's interesting. I said errno equals this, and it returned an actual string of get the current value of errno, set the current value of errno. Display a human-friendly error message. It printed it out, right? It printed out instead of the number, it printed the text. So that's fine. So we can just continue to do that. We can say eprintln message colon whatever errno tells us, right? And then standard process exit 1, and that'll be die. And so we can just call die. We don't need the break. Poll read failed, and this can be die poll failed, right? And this should give us the same. Oops, I forgot the bang. And this, oh, if disable raw mode fails, I guess we don't care if it fails because there's nothing we're going to do about it anyway. So we can just throw away that. Oh, message has to be two-stringed. Really? Okay. I thought I could just do it this way. How did I do it in my LOX code then? There's a parser. Oops. Source parser. Compiler. Oh, huh. I thought I did it that way. And maybe in the VM or in the scanner. Yeah, T into string, error message T. Oh, into. I should be using into. There, okay. So let's see, cat hi into cargo run. So we got poll failed, inappropriate IOCL for device, but device just say cargo run on its own. Poll failed, undefined error 0. So we didn't get an error out of poll. We got a timeout out of poll. Okay, so now we have, oh, because it's equal to okay false. So match poll duration. It's okay for the poll to fail with an okay false. Okay true is this code here. Okay false is do nothing, and anything else is going to be this poll failed. And then of course we have to reformat that. Okay, let's try that. Yeah, okay. Okay, so this part's working. I can hit Q, and if I say echo hi into cargo run, and we get a poll fail. Okay, so I think we're at the same kind of level as this now. We have a die function, and we disable raw mode when we die. Oh, well, I guess they do it the other way around. They try to disable raw mode, and if that fails, then they die. Okay. So this just about concludes this chapter on entering raw mode. The last thing we'll do now is split our code into sections. Okay, so we should have like a terminal section and a main section, sounds like. Although we kind of already have that, right? Because our cross term does the terminal enable raw mode, terminal disable raw mode, and we have die down here. So I think we're okay for now. Let's see how things go. Here, press Control Q to quit. Last chapter we saw the Control key combined with the alphabetic keys seem to map to bytes 1 to 26. We can use this to detect Control key combinations and map them to different operations. All right, so now they're saying it's Control key, right? This thing is Control, but this should also be a. There should be also, yeah. This all comes out of is. But there should be like a, what is the Control key without having to do this. But okay. So what we're going to do is we're going to modify. Let's modify it so we need Control Q. So if C code is this and C modifier, is that what's it called? Modifiers equals control. But of course control comes from cross term. Let's find out. Key modifiers. Represents key modifier shift control alt. So it can only just be one of them. Returns an empty set of flags, returns a set containing all flags, returns the raw value of the flags currently stored. That's the bits. Is control, or do we have to just compare it? Do we just look at the key? See, this is private fields. Where were we? I want to go back to the key code. Right, so we get a key event. It does contain key modifiers, and how do you get? Okay, so these are bits. They're bit flags. So how do I determine what the key modifier is? I mean, there's got to be a way to look it up. I can look at modifiers, but then key modifiers itself has private fields. If we look at the source for this, pub_struct key modifiers is a U8, and it has these as, oh, it doesn't have any private fields. It's just a U8. So can I say modifiers is equal to control like that? Or do I have to do this? And oh, I probably have to say key modifiers in front of it, right? Oh, event key modifiers. Yeah. What's it complaining about? Key modifiers is a struct. Oh. Oh. So, like that? There's no control in event. No. By pulling key modifiers like that, what am I doing wrong? How do I use these? Contains. Returns true if all of the flags in other are contained within self. So I can say key contains, but then what do I put here? I want to put control. But control is not a thing, not found in the scope. Let's take a look at let's take a look at the repo. And see how it gets used in the examples. Yeah, key modifiers, : control. But I thought that wasn't going to work because it's... All right, I'm confused. Why couldn't I import it up here? I guess I couldn't. All right, so cargo run. Now it should be control Q to get us out. So I can type Q. If I hit control Q, yes. That gets us back out. Okay, so that's that part. Refactor keyboard input. Let's make a function for low-level key presses reading and another function for mapping key presses to editor operations. We'll also stop printing out key presses at this point. Okay, so we have editor read key. So this basically just blocks on reading a character and then returns the character. And then editor process key press. Okay, so let's make a keyboard handler function or a keyboard file, and we can just say pub fun editor read key. We don't care about anything else. And then, oops, let's pull this out of main here. All we're going to do is read, right? So that's all we have to do is use cross term event read. And this is going to return, I guess, a key event. That's all we care about, right? And if it fails, we're going to die. So we're going to say if let OK event equals read. Then we are going to return the event. So I put the event, but then else die read. I don't know if that's going to work because it's going to say that the two arms don't return the same thing, not found in the scope. Key event comes from event. Okay. So this is this, and then event, key event. Okay. Isn't that how I got it? I guess I can do that. No, key event still doesn't exist. Okay. Must be in a different place. Key event. Cross-term event, key event. It's right at the top. There. And die is not found in the scope. It's up here. If I make it pub, do I have to say use create main star? No. Could not find main create root. Okay. Get a little further. Yeah, now we have mismatched types because we're not returning a key event. So maybe we give it a result. Die never returns though. Oh, expected one argument. Why? I thought results had to have two different things. Oops. There. Nope. Okay, key. Okay event. Oh boy. Nope. Expected key event found. Event dot. Oh, okay. Right. We have to extract the event. And how do we do it here? If okay, and then if let key event is that, otherwise we're going to loop, right? So let's do that. Loop. If let okay event is read, if let key event equals event, return key event. Otherwise we're going to keep going. If the read fails, I don't know how that showed up. And then this, right? Okay. And now we can't do an error this way, right? Expected blah found enum result. Expected this to be empty. Really? Break. Panic. Should not get here. Or unreachable, right? There. Oh my god. Okay, and the warnings are we're not using keyboard. That's true. We're not using keyboard yet. Okay, so we were able to pull out editor read key and then editor process key press. So this should be okay, so this is the terminal side of things. And then process key press is the input side of things. So let's make an input file. And just say use create keyboard star hub editor process key press. Let C equals editor read key. Right? And then match C, and that's going to be a key event code Q modifiers key modifier control standard process. Oh, we can't do it. We can't just do exit 0, right? We have to clean up the terminal. So I don't want to do that just yet. And anything else, ignore. And we need to pull in the key modifier thing. Main first. Oops. We'll need a mod input. Input star. Black Udon, hi. Fun. And right, so in main, we also need to, it's key modifiers, control. So this is use cross term event key modifiers and key events. Key event is event key event. And what are we doing here now? This expression has type result, expected enum standard result found key event. Oh, okay. It should be okay. Key event. Right? And then this doesn't like this. Expected enum key code. Oh, key code. Wow, okay. This is a lot more annoying. Key code and then char, right? And then Q. Like that. Undeclared type key code. There. And now we have warnings because we're not using anything. Okay, so what we need to do now is look here. So in our main, we enable raw mode. We go into a loop and then just call editor process key press. And I'm going to have this return a bool for now because I want to then break. And all of this can go away, right? Boom, gone. So now we loop until editor process key press returns true, which is going to do here. Return true. Otherwise we can, oh, yeah. Help use a comma. False. I guess we can just do it as part of the match, right? Oh, now we're not using a whole bunch of things. Okay, so we'll fix that up. We're not using keyboard. Oh, this uses keyboard. Main does not. Right, so we don't need duration. I don't think we, we do use Erno down here for die. We don't use keyboard, but we do need to mod it because otherwise it won't build. And then we have a bunch of things here we're not using. Poll, read, key code and key modifiers. There we go. Okay, so editor read key's job is to wait for one key press and return it. Right, so if I take a look at that, right, we're going to block here on this read. We're not doing the polling thing right now. Later, we'll expand this function to handle escape sequences, which involves reading multiple bytes that represent a single key press, as is the case with arrow keys. So that's one of the things we don't have to worry about with this one is the arrow keys don't need to. We don't need to worry about the arrow keys being escape sequences because crossterm handles that for us. Editor process key press waits for a key press and then handles it. Later, it will map various control key combinations under the special keys to different editor functions and insert any alphanumeric and other printable keys characters into the text that's being edited. Notice the editor read key belongs in the terminal section because it deals with low level. I put it in keyboard. And whereas editor process keys begins in the new input section. So I created an input, which of course is not in Git files. All right, well, let's see if this builds. I mean, it does build, but does it do the thing that it needs to do? I want to be able to, I can type a bunch of things. I hit Control Q and we exit. Okay, so that's kind of working. And we reset the terminal correctly. clear the screen. We're going to render the editor's user interface to the screen after each key press. Let's start by just clearing the screen. So now we have an output section. Okay. Let's commit these. Oops, I didn't want to do that. Yeah, this we can clean up later. Cargo git status, git add source and cargo toml, git commit -m editor up through step 21. Okay, so step 22 is to create output, and this is just going to be pubfun editor refresh screen. Now this has a weird escape sequence. I think it's just the clear screen. Oh, refresh screen. I see. The 4 in our right call means we're writing 4 bytes out to the terminal. Escape, which is 27 decimal. Other 3 bytes are open bracket 2 capital J. So J means erase and display to clear the screen. Escape sequence commands take arguments. So we should have a clear screen thing in here, right? Clear. Terminal clear. A terminal command that clears the terminal buffer. Okay, so one of the things that we have are these commands. Let's take a look at, yeah. So there's a whole bunch of things here. Oh, sorry, Black Udon, I missed your thing. I tried to use Rust for embedded, but I could not set up the environment from the tutorial. Oh, then let me share this with you. Check this out, because this shows you how to set it up with no standard library. This thing creates a freestanding Rust binary, which allows you to do embedded programming. Sorry, Black Udon, I missed your comment earlier. 11 Wyverns, hello. So yeah, let's take a look at what options we have here. We have these commands for the cursor in the cursor module: show hide, enable, disable blinking, save and restore position. There's mouse events, which we're not going to deal with. We have color events. Yeah, so here's clear. And how do we use it? Because it's a struct. I can't call this struct. So how do we use this? Yeah, let me know how that goes, Black Udon. I would love to see some embedded examples. I know that Oxide Computer Company is making an embedded OS with Rust, and they have their thing up on GitHub somewhere. GitHub Oxide Computer. Yeah, I've already looked at it. So they have this thing called Hubris, a lightweight memory protected message passing kernel for deeply embedded systems. So this would be a good thing to learn about and see how that works. All right. Right, we can't just call a struct. So how do we use this? How do we clear? Standard out Q cursor move to. So do we do that here? Terminal clear using the same thing? Use standard IO, right? Standard out. Okay. Use cross-tune queuable command. Editor refresh screen. So let mut standard out equals standard out Q terminal clear. I have to pull in terminal then, right? Use cross terminal. And then flush. Standard out. Flush. Let's go into main and mod output. Nope. Create cross-term command is not implemented for clear. Okay, so how do we clear the screen then? There's a Q macro. There's direct execution. Oh! Terminal clear type all. So it is a function. Or an enum. Anyway, let me jump to it here. It's a struct. Oh, it's a tuple struct with the clear type. Okay. Okay, so that built with 5 warnings because we're not calling editor refresh screen yet. Black Udon says hubris and humility, they name their software as if they were Greek gods. So yes, I mean, they commented on the fact that, you know, making a brand new operating system from scratch takes an incredible amount of hubris, right? And then their debugger is called humility, which is what you get when you have too much hubris, right? So the names are very amusing. All right, so that built. Let's see what else are we going to do, right? So we call editor refresh screen and then editor process keypress. So if we put that in our while loop, which is in our main, so we call editor refresh screen. This is not a very rusty way to do it, but that's okay. And then use output star. I mean, Rust, we would create a struct with all the stuff and then just call the stuff on the struct. So we're down to 4 warnings. Oh, result that must be used. Okay. What do they do here in the example? They just put question mark and they return results. Got it. So we can do that here, right? We can say if enter refresh screen is error, die, unable to refresh screen. Right, so that handles that error. Oh, we have to return it. Results. Like that? Yeah, see, this one's saying 2. So is there one in here? Use cross term. Yeah, it's result right there. Implicitly returns. Okay, so okay. There, that's better. Now we're down to 3 warnings. Cursor is not used. And standard out flush has an error that needs to be dealt with. Question mark. There we go. Okay. So now, if we run this, cargo run, it clears the screen. I can type some random characters, and if I hit Q, Control Q, there we go. So it is clearing the screen. It's leaving the cursor at the bottom. That's okay, right? I'm sure we'll get to that point at some point. Right, we're not writing an escape sequence, so we don't have to worry about it. And there we go, reposition the cursor. You may notice that command left the cursor at the bottom of the screen. Let's reposition it at the top left corner so that we're ready to draw the editor interface from top to bottom. So in output, we will queue up, and I think you can chain the queues, right? Yeah, that's what I saw. Okay, and then cursor move to, excuse me, dot q, cursor move to 0, 0. I assume. Question mark. And then I bet you there's a cursor. I wish I had a command here that would clean up my, because I should put result and queueable command in here. I like the standard ones at the top. So if I leave a blank line, then Rust format won't do that. Okay. So now let's see, cargo run. Okay, now the cursor is up here. And Control Q gets us out. Nice. All right, we're getting there. That was step 23. And then clear the screen on exit. Rows and columns are numbered starting at 1, not 0. Oh, is that true of cross-term as well? It is not. Okay, so that's good to know. So it starts at 0, 0. If you have an 80 by 24 size terminal, you want the cursor in the center screen, and you can use 12 semicolon 40, but H defaults to 1. Okay. Control Q. Yeah, then we have a no new line thing. Okay. So let's undo that. Okay. And then clear the screen on exit. Let's clear the screen and reposition the cursor when our program exits. If an error occurs in the middle of rendering the screen, we don't want a bunch of garbage left over on the screen. And we don't want the error to be printed wherever the cursor happens to be at that point. So, okay. We have two exit points we want to clear the screen at, die, and when the user presses Control Q. We could use that exit to clear the screen, but then the error message printed by die would get erased right after printing it. So what we're doing here is clearing the screen and moving the cursor to the top at exit. I guess we could do that in main. We disable raw mode, and then we clear the screen here and move the cursor. I wonder if we should just make that a separate function rather than having it. So if I take a look at our input, how do we do it? Oh, in refresh screen. Yeah, so we queue up these things, and I don't want to create a standard out each time, right? Every time we refresh the screen, we got to grab a new standard out to write to. I guess we can clean it up later. It would be nice to create an editor struct to put all the stuff in. But then the impl would have to be all one file, right? With all the inputs and the outputs all in the same spot, which would make a very, very big very, very big impl section. Okay, so how far are we with this? Oh, we're just beginning. I didn't realize that this section 3 was so big. Okay, let's do this. Let's add this in here, so we can create a separate function here. Pub fun clear screen result. And maybe we can pass in standard out. Ooh, what type is that? Let this equal standard out. I need to know the type because if I'm going to pass it in, oh, it's just standard out. Okay. So I can say standard out is mut standard out, like that, and then just and then flush. Can I do it all in one step? And then we can just say clear screen, standard out, and not worry about any of that stuff. And then we'll leave the flush in there because I'm sure there's going to be other things we're going to do. And that doesn't work. And now results. Ooh, how did I do that? We'll get there. It's mutable. Oh, I have to pass it in as mutable. Okay. Warning is clear screen has a result that must be used. Boom. Done. Okay, so now when we die, we'll also disable raw mode and clear the screen. I guess it doesn't matter which order we do it in. Clear screen, let underscore equals clear screen. Oh, we need standard out to do that. Let mod standard out equals standard out. And now, of course, we don't have that. So maybe I should put die as part of the output. All right, make that here. And then we shouldn't need any of these things, right? And Erno can go over here as well. What am I missing? Oh, I forgot. Oh, I just inserted it in the wrong spot. Okay, and then terminal. Oh. No. Oh, this is the wrong file. Yeah, this is where terminal needs to be, right? Where is it? There it is. Took me a while to find that in my cut buffer. Okay. So that builds. So now we should be able to clear the screen, although we already cleared the screen and nothing happens anyway, so we're not going to see anything. Tildes. It's time to start drawing. Let's draw a column of tildes on the left-hand side of the screen like Vim does. In our text editor, we'll draw a tilde at the beginning of any lines that come after the end of the file being edited. All right, so editor draw rows. So in output, well, let's right, I'm not going to worry about that. Git add source, git log. We did step 21. Okay, git add. Oh, git commit steps 22 through 24. Okay, I should do one step at a time, right? For my commits. I'm barreling it on. Okay, and so this one step here is just editor draw rows for the output section. So let's take a look at output. We can say pub fun editor draw rows. Is everything going to start with the word editor? And then this just draws 24 tildes. Okay. In 0 to 24. Crossterm was warning us, use write instead of, when we were in raw mode, right? Where was that raw? Here it is. It says use write instead. So we can do that. But we're going to need to write to somewhere. Oh, maybe we just need to use cursor event style. How do we just do basic printing? Or is that the way we do it? Because I want to actually queue up the print commands. This is self-stylized. Can I just print non-style content? What does style do? Style. Colors. Attributes. Okay, bold, underlined, and negative. I don't know what negative means. So you can just do print. Can I do that? Can I say let mut standard out equals standard out? And then for row 0 to 24. I don't know why we're hard coding it to 24, but we are. We can say standard out dot q of move to, I think it's row column. Oh, sorry, cursor. Followed by q of print. And I think I can just do this, dot toString. Oh, and I have to put question marks, right, for each one of these. And then that. So this needs a result of this. And then after that, we can say standard out flush, question mark, and then actually we could just do this, right? We don't need to do the business with OK. If we can just eliminate the return code there. Didn't like that. Oh, two columns. Oh, and we need to pull print in. Style : print. There. What's the warning? Editor draw rows is not called. Okay, let's fix that. That's in editor refresh screen. Clear screen. Editor draw rows. Oh, okay, then we can just pass in standard out. Let's do that. So we don't actually need to flush everywhere. We can just do this, right? And then just have one single flush. No, for clear screen, we want the flush there because we're calling it from die as well. So I can do that, but this can do this. Nope. So we do need that, and then this can just do the flush down here. Editor draw rows and then flush. This looks like it's moving back to the top again. So maybe we do that. Okay, let's pass in the standard out. And then we have to do it this way. And then before we do the flush, we're going to do an editor move to, q cursor move to, right? That's what the H is doing, right? Is going back to 0, 0. Question mark dot flush. Okay. Yes. Editor draw rows will handle drawing each row of the buffer, the text being edited. For now, it draws a tilde in each row, which means that row is not part of the file and can't contain any text. We don't know the size of the terminal yet, so we don't know how many rows to draw. For now, we just draw 24. After we're done drawing, we do another escape open bracket H to reposition the cursor back up at the top left corner. All right, so let's see if this works. Cargo run. I wonder if they're going to talk about the alternate screen. Oh, I got row column backwards, didn't I? Okay. So it's column row. There we go. And now Control Q does clear the screen. Okay. All right, so that was step 25. Git status cargo. Oh no, git add source. Commit hm step 25 drawing tilde characters. Okay, let's do one more and then call it a stream. Our next goal is to get the size of the terminal so we know how many rows to draw in editor draw rows. But first, let's set up a global struct that will contain our editor state, which we'll use to store the width and height of the terminal. For now, let's just put our origin termios global into the struct. All right, so I think this is where we need to do a bunch of refactoring, right? Because I want to put all of these things in. If I create a flag, like an editor rs, and we can say pub struct editor, and we're going to stick, right now we're sticking termios in here, but we also want to stick the window size. So we're skipping step 26 because we don't need that. Struct win size. Where does that come from? Terminal IO. Terminal IOC, right? Get window size. Yep, that's what he decoded it to. Okay, so this does return a win size struct, and so crossterm should have a window size, right? Terminal size, and what does that return? A pair of U16s. Top left cell is represented 1, 1. But didn't we just try the 1, 1 and it turned out to be wrong? Sys size. All right, well, we can create this. Let's create a width U16 and a height U16. And we can create in here a get window size, right? Impl editor pub font new self, and then we have to pull in crossterm terminal size. Something was going wrong there. Let width of columns rows equals cross term terminal size. That's all we have to do, and then we can say self width is the columns and the height is the rows. Like that. And of course, nothing's going to work because I didn't stick it in here. Oh. Okay, and we're not using it yet, so source main, terminal enable raw mode, let editor equals editor new. Use editor colon star. And I think what we're going to do is we're going to move all of these refresh screens and process key presses into the editor. Right? And we're not using it yet, but we can see what it's going to do here. We set the calls and rows. And then we're going to use that to determine, oh, yeah, we want to die if that fails, right? If let, okay, editor, no, we can't do it that way. I guess I could just do that. That's cheating. Okay. Width and height's not used. Okay, so yeah, I think the next step is to do refactoring, right? Move all of these things into the editor. It's going to have to be mutable. I guess we can, all of this stuff that we've already done, that's unfortunate. Source editor. Yeah, because now everything is going to be in one giant file. So that's editor, process, key press, and then we have this goes here, and then we have output, right? I guess die is going to be separate, right? Oops. We have a bunch of redundant uses now. I don't know how to clean that all up. What's the first error? We already have that. This should be editor dot, right? And I actually have to change that now because all these need to change. Method not found in editor. Refresh screen. Where's refresh screen? It's right here. Oh, did I? Yeah, I did. Okay. Self. Oh, right. Okay, and this is actually something we can do is grab at the beginning of the editor is grab the standard out. Editor read key is the other one. Editor. Self. Uh-oh. Oh, this is in die. Right, okay. Which shouldn't be in here. Read not found in the scope. Really? We've got so many imports here. Yeah. There's no read in root. Okay, where's read? I'm rushing because I need to finish. I need to go. Read event. Okay. And then key. Oh boy. Where was read key? Input. Oh, and I cleared it out already. Key comes from event key. And die, self die, editor die, process key press. Oh, editor, okay. So, no, it's just process key press. So, okay. All right. So it builds. We have 10 warnings because we're probably doing all sorts of things wrong now. Cargo check. All right, let's clean up these warnings. Actually, that's right. We're now source. Let's see. WC-L source stars. So input can go away, and output can go away. Oh. It has modifications. All right, let's clean that up. Source. Oh, what's in keyboard? Keyboard should be empty too. Yeah. Okay. Good enough. And then, so everything's in editor now. And what do we got? Let's clean this up. Unused import. Oh, in main. We probably don't use any of those, right? Oh no, we use terminal and result. That's right. Unused import keyboard. Unused import create keyboard. Oh, there. Okay. What else? Unused import out. Right, because we don't have output or input or keyboard anymore. Enter doesn't need to be mutable yet. And then we don't use width and height. I guess what we can do is this println editor stats. Like this, and then just implement debug for editor. Derive debug. So we're still not using them. Dang. So debugging output isn't going to help. Oh, so yeah, what we can do is for width, we ignore that, but we have the height of 24 here, which we can do, say, self height. Okay, that should get us down to 2 warnings. Git status, git add source, git commit -m, refactored into an editor struct. Now can I delete those files? Git rm source input, source output, and source keyboard. Git commit -m cleanup. Git push. All right. That was a little rushed right there at the end, trying to clean things up, but we got through step 28 almost. Yeah, we did step 29 sort of to print the number of rows. We didn't actually test it. Cargo run. Yeah, so now it does tilde us for the entire screen, and Control Q gets us out. Okay. And Clippy is still complaining about the match. Yeah, that's fine. All right, so that's that. That's my Friday stream. Monday, we'll continue working our way through this chapter, and then we need to get back to garbage collection on the interpreter. So we're gonna change things up and have a little bit of fun. All right. So that's the stream. Yep. Have a great weekend, everyone, and I will see you next time. Take care.